I want to show one thing. Mpsk means actually multi-level modulation technique permits high data rate within fixed bandwidth constraints. And already I told you everything. M is defined using this combination, m equal to 2 to the power n. This is the most useful expression. That means a within this TV interval only single bit may be transmitted. Now I want to transmit n number of bits. Each of the m signals that can be said as a single symbol. And I told you it is possible for Mask, it is possible for Psk, it is possible for Fsk. It is also possible for the combination of amplitude and phase modulation, that is quadrature amplitude multiplexing. It may be 16 QAM, it may be 32 QAM, it may be 256 QAM, anything. Now, how to describe it mathematically? When I want to write binary phase shift keying, I want to write only the amplitude in terms of energy by time interval into cosine. Its argument, either it is 2 pi fct or 2 pi fct plus pi. Now, when I want to write, it is for m number of levels. If I have 8 levels, then how to obtain all those 8 levels? By dividing your 360° in this way, where you have first level is present at say 0°. After that, it may be present at 45°, then 90°, then 135°, then 180°. Now 5 1. This one fifth. At 180° phase, your fifth symbol may be present. After that, 225. Next to that, your 270. After that, you have your 315°. So when it is acquiring 315°, that means 8 level that can be passed. So 8 different levels are there. So how to define it? When I want to start it from 0, that means 0 to 7, these are the 8 different levels. And I can write, this is first one, then 0, 1, 2, 3, 4, 5, 6, 7. How to write it? Then 2 pi by m, 2 pi by 8. M is say 1. Then I can write 2 pi into 1 minus 1, 0 by 8. That means 0°. After that, 2 pi into 2 minus 1 divided by 8. Then you are getting 2 pi by 8. When 2 pi minus 2 pi into 3 minus 1 divided by 8, then you are getting 90°. In this way, you can compute your different phases. And if I can put all those phase relationship here, then you are getting different signal representation for different levels. When it is quadrature phase shifting, there are only 4 levels: 0 to 0 to 0 to actually your third level. That means actually you have 45°. After that, 35°. Then next to that, you have your 225°. Last one is 315°. This is Qpsk. When I'm talking about Mpsk 8 levels, then it is uh, represented by this mathematical representation. Okay, so actually we have found this mathematical description. Okay, when it is okay, very good. When I'm talking about QPSK, you are right. When I'm talking about m equal to 2, then it can be started from not only from 2. This is not the right convention, then that you can start m from the value 2. You need to start from 1. But in case of QPSK, this mathematical representation that can be written as 2 pi by m. 2 pi by m means 2 pi by 4. So you are getting your different angles like 2 pi by 4 means 360 degree by 4, that means 90 degree. So first angle, that is 90 degree. But we are getting what? We are getting 45 degree. How to achieve it? Using some mathematical calculation, that is 2q minus 1. Instead of m is there as 1, we need to write it is some even number. It is any number, any integer. But when I'm talking about QPSK, it is only possible for QPSK when I can write m as some even number. Then you can write 2q minus 1 or 2q plus 1. But if you can write 2q plus 1, one value can be shifted out. So you need to start it from 2q minus 1. Ultimately, you are getting this Mpsk representation. And this is the basis function without energy. When I want to compute the signal space representation, obviously you need to use trigonometry, and you are getting your energy with some phase, in phase component and quadrature component, with first basis function, with second basis function, and you can compute your signal space points. This is the nice constellation diagram. When I am talking about BPSK, there are only 2 points. Only 2 points. Only 2 points. One is at 0 degree, another one is present at 180 degree. When I am talking about QPSK, there may be some shift from 0 degree to some 45 degree position, and next to that 135, 225 and 315. So this is QPSK. When I'm talking about 8PSK, this is the constellation diagram, and when I'm talking about MPSK, we are getting this constellation diagram. Ultimately, using Euclidean distance, when I can compute it, then we will get the complementary function q with this argument. This is the error constellation. This is a calculation of your error probability of PSK for error performance comparison purpose. So I told you what's the problem in case of Mpsk. The design issue is quite critical as compared to our BPSK. Thank you. Thank you for your nice patience. Already I have explained a generalized model of PSK, which is known as MID PSK. Today, again, I'm going to tell you some information regarding the issue of QPSK. What is QPSK? QPSK is MID PSK, but that time 2 to the power small n is equal to capital M, where small n is equal to 2. That means 4 different levels. How to define it? Already I told you that pi by 4, next to that 135 degree, then 225 degree, that can be written as minus 3 pi by 4. After that, minus pi by 4, that means 315 degree. How to relate them? Based on the graphical plot of phase relationship, that can be defined in this way: voltage and phasor relationship in between two signals. Say this is one signal and this is another signal. How much phase difference between them? That is 45 degrees. How much phase difference between these two signals? That is 90 degree plus 45 degree. How much it is? 135 degree. When I'm talking about 225 degree, that means 180 degree phase shift, and 45 degree, then next just 180 degree opposite relationship, just inverted in terms of pattern. Y-axis, this is one y-axis, say it is y1 and y2, then it can be just a replica as opposite replica. That means y2 is now at the above position and y1 is now present at the down position. Okay, so that is 225 degree. When I am talking about 315 degree, that is y effective but just the negative of your this relationship. Okay, now this is relationship of different phases. Okay, so actually these two things are quite similar. So these two things are quite similar, whereas these two things are quite similar. That's why this one and this one is similar, but the phase difference just opposite to each other. When I'm drawing with respect to some time response, then we are getting this effective phasor diagram, where something is relationship is there. This is in phase component, I component, this is quadrature component, Q component. When I can combine these two together, then I'm getting this QPSK output. How to generate QPSK signal? What are the necessary blocks? First, I need serial to parallel converter. Next to that, I need two product modulators and one oscillator. That oscillator can generate carrier signal, high frequency carrier signal, similar to our analog communication locally generated carriers. Now, when it can be generated, what is the mathematical description of QPSK? That is in phase part with multiplied with in phase part is multiplied with your cosine function, and quadrature part is multiplied with sine function. And when you can sum together, it is, you will get your ST. You know, any QPSK signal that may be used to transmit 2 bits at a time at a particular bit interval with duration. We want to send more than a bit. We want to send 2 bits at a time, 2 bits at a time, which is known as dbit. Okay, dbit or dibit, whatever it is. So there are 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. When I want to use some graphical representation that have some phasor relationship, it may be considered 4 different phases over the 360-degree angle. Either you can use 0 degree, 90 degree, 180 degree to 70 degree. Again, back it into the 0 degree level. Then you will get 0, 0, 0, 1, 1, 0, 1, 1 like combination. Now, when I'm talking about other way, that means the 0 degree that may be shifted towards 45-degree position. That means now everything can be shifted by 45-degree angle, and you are getting 45 degree, 135 degree, 225 degree, 315 degree. These are the 4 different angles. Now, how to take those angles for different combinations? There is 0, 0, 0, 1, 1, 0, 1, 1. They may be represented by different angles. You can take this way, pi by 4, that may be present at this first quadrant, which is used to represent the information 1, 1. When I am talking about 3 pi by 4, this is 3 pi by 4. It is used to represent the bit pattern 0, 1. You can take minus 3 pi by 4, which is our actually 270-degree angle, 5 pi by 4, which may be written as minus 3 pi by 4, which is used to represent the bit pattern 0, 0. On the other hand, when I'm talking about minus pi by 4, minus pi by 4 means you're actually 7 pi by 4, 315 degrees. It is used to represent 1, 0 combination, but this convention is not universal truth. I want to say that this convention is not universal truth. You can take other convention also. When I want to take 1, 1 as 45-degree angle, then you can take 135 degree, that means 3 pi by 4, which is now represented by the bit combination 1, 0 instead of previous convention 0, 1. Now when I am talking about 225 degree, that means minus 3 pi by 4, which is now 0, 1 instead of 0, 0. Okay, so last thing, when I'm talking about 315 degree, which is simply like minus pi by 4, previously it is used for 1, 0 convention. Now it is taking as 0, 0. So you can take any convention, it's your choice, and you will get your output. Okay, so after that, what I want to tell you, QPSK already I have discussed, that may be generated using this way, where serial to parallel bit converter is there, and 2 product modulators are there, 1 oscillator is there. Oscillator is used to generate the signal, cosine signal, that may be pi by 2 phase shift, and you are getting your sine function. When quadrature part is multiplied by sine, you are getting some part, that is quadrature part. In phase part is multiplied by cosine function, you are getting in phase part. When you can combine these two things, you are getting your final output at this end. And what I want to tell you, last day I have not discussed this thing, offset quadrature phase shift king. What is offset quadrature phase shift king? Just this QT portion, that means quadrature part, is shifted by TB amount of phase delay, TB amount of time delay. So you are getting, instead of QT, now you are getting QT minus TB, which is now multiplied by sine function. So that means your quadrature part is something different as compared to QPSK. So offset delay is there.